Hi, it's Mr. Rops here, and we're going to talk about graphing rational functions. When I look at the graphing rational functions, the first thing I think about, there's always four things I consider to start off with, are my vertical asymptotes. And when I look at the vertical asymptotes, the key that I look at is always the denominator of my fraction. So I'm going to take the 2x plus 5, and I make sure it's not allowed to be 0 on the bottom of a fraction. So that's going to be my domain is going to be restricted there, which means wherever it would be 0, there's going to be a vertical asymptote. So I save the denominator, solve for the denominator equal to 0, and I get x being negative 5 over 2. Now I'm going to take that information and store it here, just so I can keep track of it when it's time to sketch it. So vertical asymptote, x equals negative 5 over 2. The next step that I consider are my horizontal asymptotes. Now, for what we study, we consider two different scenarios. We look at the degree of the numerator, and the degree talks about the exponent of the x, and the degree of the denominator, the largest exponent x here. If the bottom is larger than the top, so this exponent that would be right there, if that exponent would be larger than this exponent, which in this case they're the same, they're both equal to 1, but if the denominator is bigger than the numerator, then the horizontal asymptote is y equals 0, which is the x-axis. Now in our case, both of these exponents are exactly the same. And so if they're exactly the same, I'm going to look at specifically the coefficients there. So I'm going to look at the 6 and the 2, since it's x over x. I'm going to look at that. And so I look at my horizontal asymptotes is going to be y equals 6 over 2, which is 3. I'm going to write this over here, keep it all together so I can use all my information to sketch. So y equals 3. The next thing that I'm going to consider is going to be my intercepts. So let's look first at the X-intercepts. The X-intercept is when the function itself equals 0. So that means 6x minus 12 over 2x plus 5 equals 0. Two ways you can think about this. I can cross multiply, assume there's a 1 underneath there. 2x plus 5 times 0 equals 6x minus times 1. Or if I think about fractions, if I want a fraction to be 0, the top has to be 0. So 6x minus 12 equals 0, which means that x equals 2. Subtract the 12 divided by 6. And so I have an x-intercept at x equal to 2. So my x-intercept, x equals 2. Now the last piece of information I need to consider is my y-intercept. See if I can squeeze this in the side here. And for my y-intercept, anytime for any type of graph or a y-intercept, I always let x equal to 0. So if I plug 0 into my function, f at 0, I get 6 times 0 minus 12 over 2 times 0 plus 5. If I simplify that, I get negative 12 over 5. Well, that's just a little bit more than negative 2, so it's negative 2.4. Okay, so now my y-intercept is y equals negative 12 over 5. And now it's just a matter of putting this information on. My vertical asymptote is, here is negative 5.2. I can do this with a dotted line. Let's see if I can figure this out. I'm going to go down here, about there. My horizontal asymptote is around 3. Okay, and so now I have to find my x-intercept is at 2 here. My y-intercept is at negative 12 over 5, which is around negative 2 and a bit. So I have 4 parts here. This one here is definitely going to be below the asymptote here, and so I can sketch it roughly here. Now, to find the other half, is it going to be below this horizontal asymptote or above this horizontal asymptote? Well, experience tells me I know where it's going to be, but if I'm not sure, what I start to do is I pick a point on the other side of negative 2.5. So let's pick, I don't know, negative 4, let's say. And I'm going to plug in f at negative 4 into my function, which is 6 times negative 4 minus 12 over 2 times negative 4. And I think it's plus 5 if I'm not mistaken. Plus 5. Plus 5. Well, that's negative 24 minus 12 is minus 36 over negative 8 plus 5 is negative 3, which is 12. So when I have the point negative 4, I am way up here at 12, which means that this graph has to be doing something over here that we can't even actually see. But if I'm sketching it, it's going to be something like that. That's a pretty messy sketch, but that's the idea. It's going to be up in this corner and down in this corner. That's how we're going to check it. Now, to see if I'm correct, the easiest thing I think I can do is probably go to Wolfram Alpha, which I love this site, type it in as I've done here. You can see it's typed in here. Hit enter, and you see I get this graphs here. And so it goes at negative 2, negative 2.4, and it's up here as well. And there's the asymptotes as such. Alternate forms you can see here is your asymptote, your horizontal asymptote. All right. The other thing you can take a look at is you can also graph it on your calculator. And if I put it in my calculator, I turn my calculator on, turn the graph on, take a look. You see that. Now, this line here is just the calculator not understanding how to connect the points. It connects all the points and it goes, oh, connect. But there you see what the shape of the graph looks like. This wraps up graphing rational functions.